Hi everyone. First, thanks a lot for being here today. So today's session will be about exchanging messages with Ceph eDelivery. Ceph eDelivery, which is one of Ceph building blocks, enabling the secure and reliable exchange of data and documents. So I'm Manon Tenard. I'm the onboarding manager of Ceph eDelivery, and today I will be the moderator for this session. So for today's session, we will have two speakers. We will have first Bogdan Dimitriu, who is IT project manager for Ceph eDelivery. And then we will have Victor Diaz-Garcia, who is a member of the Ceph eDelivery support office. The support office, which is in charge of providing technical support to Ceph eDelivery users and operating the various services offered by Ceph eDelivery. Can you please change the slide? Thanks a lot. Okay, so note that this event is an interactive event. So please ask your question in the dedicated area, which is the Q&A area, not in the chat, please. Note also that this event is recorded, so please ask your question anonymously for data protection purpose. Okay, next slide. Okay, so for today's agenda, so first we will have an introduction to Ceph eDelivery by Bogdan Dimitriu. Then we will have a demo on sending and receiving AS4 messages by Victor Diaz-Garcia. And then we will finish with a Q&A session. So please feel free to ask your question during the presentation. And then at the end, I will take your question one by one, and then we will be able to provide you an answer. So now I will give the floor to Bogdan, please.
Thank you very much, Manon, and also good afternoon from my side to everyone in the meeting, to everyone connected, let's say, virtually to the meeting. I am Bogdan Dimitriu, and I am the project officer in charge of the Ceph eDelivery project. Indeed, I will be leading off the webinar today with a few slides explaining eDelivery, mainly, let's say, targeted for people who are not familiar with our building block. So I just, knowing that we have quite an audience, I want to properly scope the session and clarify that this is about an introduction to eDelivery. So if you are familiar, you are bound to hear some things that you already know, but I think it might still be interesting nevertheless. So if you could maybe move 2 slides down, Victor, that's great. The building block, the Ceph eDelivery building block, is part of a larger family of building blocks that were developed under the Connecting Europe Facility program. And of course, you are participating at this 3-day conference. Well, some of you, I'm sure, are only attending a few of the sessions, but this is part of a bigger conference, a 3-day conference on the closure of both the Connecting Europe Facility and the ISA Square programs that took place over the past 7 years. And eDelivery, that is the focus of the webinar today, is under the Ceph side of things, so to speak, where, of course, a lot of things were developed, among which what we call horizontal DSI, consisting of building blocks, such as the ones that you see on the right-hand side. The main concept of developing these building blocks was to provide a set of standards and specifications that can be used to promote interoperability across, well, mainly the European Union, mainly inside the public sector, but of course not limited to either the European Union or the public sector, even though these are, let's say, the focus. As you can see on the next slide, we are part of large family that not only includes eDelivery, but also very common other solutions, such as your electronic identity, in case you want to incorporate authentication with strong guarantees in your system, electronic signature, in case, of course, you want to deal with electronic or digital signatures, electronic translation, which is, of course, machine translation of texts in from and to various languages, and so forth, and so on and so forth, as you can see collected a little bit here on this slide. And us in eDelivery, we are providing specifications and also software sample implementations to enable the exchange of data securely across borders, and most importantly, interoperably. So if you can move to the next slide. I mean, I was explaining a little bit earlier that first and foremost, each building block, each CEF building block is a set of specifications. Yes, we also deal, of course, in software products, but the core definition of the blocks of each block is specifications. So then the question is, how do we turn, and how do you turn with our help, specifications into IT systems? Essentially, you have three options. Let's say you have the option to select and buy if there is a cost to it. Otherwise, there are also open source solutions. So you have either the option to buy or directly use without paying. Compliant, interoperable solutions from the market, and there are quite a few of them, as I will explain a little bit later in the presentation. Then you have the option of building your own solution that is compliant to the set of specifications we define as part of our building block, and then we can also help you do conformance testing of your solution. And you can equally reuse the sample software that was developed as part of the building block and available on our website. And we are there to support you regardless of the option, let's say, you take for turning specifications, eDelivery specifications into an IT system. And we can guide you along the way depending on your questions and on your needs. In this slide, we want to give you a feeling about the level of adoption and also the trend of adoption of the CEF building blocks. So this slide speaks about the family of building blocks. It's not just about eDelivery. Nevertheless, we are a core part of this family as eDelivery. And you can find various ways to break down these numbers on our monitoring pages on CEF Digital, but let's say as an aggregated view, you can see that we have 167 projects that are already reusing a building block. Alongside them, 70 projects that are committed to analyze reusing a building block. 37 committed to already reuse it, so they have completed the analysis and they will be reusing it. So it's a matter of going from design to production. And finally, in terms of a trend, there is a 150% increase in reuse since 2018. Also on the same slide, you can see that the building blocks are being deployed in a wide range of domain, varying from e-health, e-justice, e-procurement, social security, but also others not shown here, such as taxation, transportation, logistics, and countless others. So this is truly a set of horizontal solutions. They are not built with a specific domain in mind. Which means they give you an interoperability layer that is very valuable, on top of which you can build your domain-specific projects and make sure that you can, when the time comes and if the need arises, interact with other domains because you've built using something that is interoperable. So if we can move to the next slide. The CEF, as even the name of the topic of the conference suggests, is has ended actually officially in 2020, and now we are on the verge of starting to work under the successor program called the DigitALL Europe program, and this is the new channel, let's say, under which we will continue to exist alongside a large number of solutions that were developed both under the former CEF program and the former ISA program, both of which are joined, let's say, in these 3 days in the conference. So we will, as eDelivery, be part of a new structure in the DigitALL Europe program, but we will continue to exist throughout the following 7 years, and you can continue to benefit from the specifications, support, and various services that are provided by the building block, even if, let's say, the name may go through some changes as we transition to our new home, the DigitALL Europe program. And with all of this, let's say layout or laying out work out of the way, I think we can finally turn to what is eDelivery itself and get a little bit more in depth on that. So I start once again by saying that the core goal of eDelivery is to provide a solution for interoperability in the area of exchanging data and documents securely over, let's say, an open network, but equally so over a closed network. So we are not network dependent. It can be internet, it can be Testa, it can be a private network. But of course, the major interest is to secure communication over an open network. That's where we provide a solution. And we do so by adopting standards that we did not create ourselves. We have selected specific standards that I will mention a bit later. And these are defined by recognized standardization bodies, initially OASIS, now even ISO has adopted the same standards. And we combine those standards and specify them to be used in a certain way so that implementers of eDelivery can be sure that they can interact with each other if they use conformant products or products that are conformant to those specifications. A further equally important goal, I would say, of eDelivery is to provide security and accountability of the message exchange. So we need to secure the exchange, and we do so by taking great care of the security standards that are adopted in our specifications, by taking care in the design of the exchanges, but also by including in our specifications ways to confirm, let's say, that a message has been transmitted, by whom it has been transmitted, that it has been received. So we provide also guarantees for non-repudiation of the message sending and so forth. So this is another chapter that is quite important and provided out of the box by eDelivery. And if you use eDelivery, then you get all of these benefits for free. So it's not something that you need to recreate. You can rest assured by building with eDelivery that you benefit from these characteristics. Certainly, we wouldn't be talking about the message exchange network, which is what eDelivery helps establish, without touching on scalability and performance. So this is mostly about scalability and performance of the eDelivery network. So if you build an eDelivery network initially with a few nodes or some tens of nodes, and then your project grows over time and you reach into the higher tens or even hundreds of nodes, it becomes less manageable to configure such a big network with static manual ways. And then we provide additional specifications and additional tools and services to allow you to grow and to make your configuration more dynamic by using something we call dynamic discovery. And this is something I will also briefly cover later on in the presentation. And finally, we are vendor and platform agnostic. So as I mentioned, there are currently 26 products implementing our exchange specifications, our specifications for implementing an eDelivery access point, and these are provided by as many vendors as there are products. We also provide a sample implementation on the commission, but let's say this is just one among many, and it's been in no case the one that we are promoting in the building block is just for supporting the rollout, but there are open source solutions. There are solutions established by companies that of course provide further support and that have an individual license. With that, we can move to the main slide, mainly, where I will explain in a logical way. So this is not necessarily a system view, but workflow view of what eDelivery tries to address. So I think that the best mental picture, and I've been using this analogy quite a lot in my presentation, so if you've heard it before, please bear with me, that you can associate in your mind with eDelivery is the postal system. So you are very familiar certainly with the way the post office works. You go to your local post office, you hand over your letter, your package, whatever it may be that you want to send, and you write on the envelope the name of the sender, yourself, the name of the recipient, whomever you are sending it to, and then you trust the post office to do whatever it does best and route your letter, your package from the post office you handed it over to a destination, a recipient post office in some far off land where your message needs to, or email, letter needs to arrive. And of course, the post office on the other side will deal with delivering this email to the recipient that was written on the envelope. What you can also take from this is that the post office doesn't care and doesn't need to care and shouldn't care what is inside the envelope, what is inside the package. And this is very similar to eDelivery. We provide you a way to say who is the sender, who is the receiver, a few more similar indications that constitute metadata, and then your payload is for you to decide. We don't have an opinion on the payload. We provide a basic structure in which to place it, but beyond that, whether you want to send an XML payload, a PDF, a document, some zip archive, or even random bytes, eDelivery will simply transport them and make sure that they arrive at the destination exactly as they were packaged at the source, and no more and no less. So how does this process happen? If you look at it, if you follow a bit now the slide, there is a sender that prepares a business message. It hands it over to an eDelivery access point, which will validate it to a certain degree, sign the message digitally, encrypt it, and send it across the wire to its counterpart access point on the receiving side, where it's decrypted, it's the signature is verified, is decompressed, and after a number of additional steps, it is provided. Let's say if everything went correctly, if there was no error, if there was no problem with validating the signature, it is provided for download for the final recipient, which of course can do so at its leisure. So we can move to the next slide now. So this is the basic model, but of course, this is a model that only shows a sender and a receiver. Of course, no IT system would be interesting if it could only support a sender and a receiver. So we are actually talking about multiplying this model in a peer-to-peer network with multiple senders and multiple recipients that are going to be helped by multiple eDelivery access points. So you see here on the slide 6 such access points, but of course you can go to tens or hundreds of access points, which establish a message exchange infrastructure. And what is interesting to note on this slide is what we consider and what is the scope of eDelivery. Where do we do our work, and what is outside of the scope of eDelivery? And that's the yellow rectangle in the middle of the circle, where you can see that we define the message, or we propose a few options and have some opinions on the message exchange model, whether it's about the topology, the messaging protocol, the integration approach. So, you know, how do you configure the access points so that they know about each other? What kind of topologies can you pull to bear? You know, do you want to have a star approach? Do you want to have a mesh approach, or something in between, a federated approach perhaps? Of course, what is the communication protocol that is used to exchange messages between any pair of eDelivery access points? And so forth. So this is something we provide information on, we provide specification on, and guidance on. Then we have a model of how do you discover participants in the network. Is it a static way? So do you pre-configure everything in a file which you put on your access point, or in a dynamic way where there are additional components in the system that can be used to discover the communication parameters of other participants to the network instead of having to pre-configure them from the beginning. And thirdly, we also discussed the security model. So how do you trust the other access points, and what kind of security controls do you deploy to make sure that both the communication between access points, but also between your IT systems that are outside of this eDelivery network and the local access point is secure. So this is in a few words what is in scope. And then, of course, as I mentioned, the network is irrelevant to us. So it can be a closed and open network or anything in between. We don't control it. As long as it's an IP network, we can work with it. And on the other side, we have, of course, the payload, which is, as I already explained, not something we have an opinion on. So you decide what you send and how you package it and what it includes, and also the data exchange agreement, let's say at the business level. So of course the user of eDelivery will need to establish some kind of business workflow to say, well, if I'm going to send you an invoice, I expect you to pay it, and this will happen through the exchange of such and such payloads. All of this is transparent to eDelivery, and it is completely up to you to set up in the way that makes sense for your domain, for your project. With this, I will move now back a bit to the two participant view, just to also provide an equivalent image in a more architectural style. So there is nothing very new here. What you see is that you have a sender information system. This is not something that is part of eDelivery. It is an IT system of your choice that you want to send or receive messages from to another IT system, which is deployed in another data center typically, or even if it's the same data center, it's part of us, or it has a different owner, and you want to ensure communication between these two IT systems through eDelivery, instead of connecting them, let's say, in a more classical way or typical way, directly through web service calls between the two systems, which of course could be interesting at some point, but they very quickly become difficult to maintain. And certainly when you move from 2 to 3 to 5 to 10, it will be completely unmanageable to know about which system provides which web services and implement support for all of them. So instead of doing that, you can introduce two additional components, two additional eDelivery access points. We call them corner 2 and corner 3 as part of the 4-corner model that is otherwise composed of the sender and receiver information systems, called corner 1 and corner 4. So the extreme corners 1 and 4 will communicate, will exchange messages or data through the inner corners that are eDelivery access points, and that between themselves communicate in a standardized way using the AS4 protocol, and a particular profile of the AS4 protocol that we have defined in our building block. So the way the message flows is that it leaves the information system of the sender. It is moved to the access point, the eDelivery access point of the sender. Then the eDelivery access point will encrypt it and sign it and do all of the things I explained with the message, and send it across the network to its counterpart access point, the corner 3 one. Upon reception and validation, there will be an acknowledgement of the message. So this provides the non-repudiation characteristic of the eDelivery system, whereby the receiver confirms in a way that is digitally signed the fact that it received the message. And of course, this also includes the hash of the original message, which guarantees that there was no modification of the message in transmission, and signed with the private key of the receiving access point to guarantee non-repudiation. And finally, the corner 3 will provide the message to the corner 4, to the information system of the receiver, for download and later or further consumption. And in the next two slides, if you can, I think, okay. I think you should go one more. Sorry, I was not aware that the slides were not keeping up a bit with the presentation. So in this slide, you see how you see the additional components that we provide for the case where instead of discovering participants statically by pre-configuring them on each of the access points that are part of the network, you want instead to use dynamic discovery of participants. So how does this work? It includes, or it involves, two additional components. One of them called SML, Service Metadata Locator. The other one called, or a set of other ones, one or many, in a small network, one is usually enough, but if you have a very large network, you may deploy more than one SMPs, so service metadata publishers that cooperate, let's say, with both the access points and SML to provide this dynamic discovery functionality. So there are two phases to this process. The first one that you see here, which is the registration phase, that is when there is an access point that is new to a network or that has changed some of its parameters. Its administrator will submit metadata about that access point to the SMP system. Then the SMP system, through the appropriate protocols, will create a representation of that participant and record its metadata. Indicate the address of the SMP to the SML system, and the SML system will register the information about where you can find metadata about the participant with the DNS system. So once this has happened, even if the SML system goes offline, let's say in case of a technical problem, the DNS system will still be able to provide the discovery function. Because other than the phase when you do the registration, there is no need for the SML to be up and running for the system to work. So this is a very nice use of the DNS system in a special way to keep track of where you can find information about each participant to the network. And now we can move to the next slide, where we have the phase 2 of the dynamic discovery, where the participant has been registered. So at this stage, when there needs to be a message sent to a given participant based on an identifier, let's say if the participant we are talking about is a company, a registered company, then an identifier could typically be the VAT number. But of course, in different domains, the meaningful identifier could be something completely different. And starting from this identifier and doing a set of nice technical, let's say, work, you can query, or the access point rather than yourself. So the access point automatically queries the DNS system, finds the address of the SMP, which contains information about the access point that needs to receive the message, downloads this information, and then uses it to send the message just like before. So the sending process is then identical to the one I already explained a couple of slides ago. So we can move to the next slide, which brings me a bit to the end of the explanation of how the main ways that eDelivery works in. And I will show you here the set of services that we are offering as part of the building block. So on the one hand, of course, we have at the bottom of the screen, and I would say this is the key part, the technical specifications for the access point, for the SMP and SML systems, alongside some guidance on how to use them. Then we have on the left-hand side sample software implementing each of these specification that we provide as sample implementations free of charge. Then we have, in relation to this conformance testing service, so this is in the middle part of the screen, which can be used by vendors of implementations of our specifications to test their products and make sure that they are conformant to the specifications. And once this has taken place, we publish and we maintain a list of conformant products on our website, so that users of eDelivery can select the best product for their particular case. We equally have a connectivity testing service that can be used to do a sanity check that an installation of an eDelivery access point has been successful and the configuration up to a certain point has been done correctly. And we can send and receive messages to such an access point from one that we maintain, so that this confirmation can be provided. And then we have a set of services linked to the use of eDelivery. For instance, a public key infrastructure service where we can provide a limited number of certificates to projects in their early stages. Similarly, a service to provide or to operate an SML products, so that systems with requirements that are not, let's say, too critical can get bootstrapped much more quickly, even if they want to use dynamic discovery, because they can rely on the existing SML system that we operate. Then we have, of course, a very capable service desk that can answer a lot of technical questions and help with troubleshooting various situations linked to eDelivery, also providing training and deployment on demand. And finally, we have a stakeholder management office as well, where we do a lot of outreach. We do meetings, individual or group meetings, or even webinars such as this one, for onboarding new stakeholders, for maintaining a rich developer community, and then publishing a number of complementary tools for self-assessment, for cost estimation, and something we will be focusing quite a lot in the future, which is a market guide, where we want to collect vendors that provide eDelivery services. So we currently have a version of this, but we want to focus a lot in the future on broadening this to a much longer, let's say, set of eDelivery service providers. And as a final slide before I hand over to my colleague, I just wanted to show you the evolution of the conformance solutions to our eDelivery AS4 specifications. So you see here, as of 2016, Q2, we've gone from 3 solutions to currently 26 at the end of last year, and already 3 more in testing as we speak. And of course, the list that I show on the left-hand side has the latest enumeration of these products. So you can see it's a very rich ecosystem that you can certainly find your preferred product from. With that, I will let you back with Manon and then Victor, and we'll be back for questions a bit later.
Okay, thanks a lot, Bogdan, for this very complete presentation. So now I will give the floor to Victor for the demo of sending and receiving AS4 messages.
Hello, thank you, Manon. Thank you, Bogdan, for your introduction. So now we are going to be following a demonstration of eDelivery AS4 message exchange between 2 access points based in Domibus, which is the software created here in the commission as a sample access point. The demo will go through the following points. We will explain briefly what is the 4-corner model, which Bogdan has already explained very well. We will define the characteristics of this scenario. As you know, there are multiple ways of setting up an eDelivery network. So the demo scenario will be based on a specific configuration. We will go through the access point configuration. What is the P mode configuration, the Domibus properties, which defines how the access point will behave and will operate. Then we will move on to the message lifecycle. What happens when we send or receive a message, an AS4 message. And the Domibus release page, so where you can find information on where to obtain Domibus. So what is the 4-corner model? Bogdan already explained very well, but this is important to go through again, because we will be using these terms very much during the demo. So we will have corner 1, 2, 3, and 4, but as we will refer to them as C1, C2, C3, and C4, where C1 will be the original sender, the person or entity that needs to send a message, a package to a third party, which would be C4. C2 and C3 will be the 2 access points, or as Bogdan mentioned, we can imagine as the post offices, where we will deliver the package and we go through the other access point. In the 4-corner model, the backends systems of the user don't exchange data directly with each other. This is part of the architecture. So the original sender does not send a message directly to the final recipient. So the message is routed through the access points C2 and C3. That's why we call this the four-corner model. The access points need to be conformant to the same set of specifications. They have to speak the same language, so to speak. And the eDelivery specifications is what define this language that is going to be used during the message exchange. So as a result, there is a wide range of access points available, and IT systems and IT operators can use one or another independently. So the demo scenario will be, we will be using, of course, the four-corner model topology. The protocol for the exchange will be the eDelivery AS4 profile, which is the default used in Domibus. The integration approach, the backend that we see here, this connector, we will be using the web service plugin. It's one of the three plugins that come by default with Domibus. If we have enough time, we will also showcase the file system plugin. And in the security layer, we will be using a mutual trust, meaning that both access points need to trust each other in advance. So it's going to be based on a static discovery. And the security control will be based in the inner security of the connector. So there is authentication and security between C1 and C2 through the connector. The demo in detail, we will be sending a message from the party A. We have called this party name Domibus Blue. And we will send a message through the web service plugin. The web service plugin, it will return the message ID that it has created. And then the message will be sent to the corner 3, and it will be available for final recipient corner 4 to retrieve. The components in the demo, we will be using a SOAP UI acting as a client as C1 and C4. SOAP UI is a industry standard tool for testing SOAP and REST APIs. The web service plugin is based in SOAP services, so this is a very common tool to be used during this kind of testings. As we mentioned earlier, Domibus is sample implementation and it's an open source project of an AS4 access point. It is maintained by the European Commission. It is a valid product to be used in a production environment. Even though we call it a sample implementation, it has production capabilities. It can work in a real production environment. And in a normal network, the users of the implementation of Domibus, in this case, they are fully responsible for its integration with their backend systems, deployment, and operations. eDelivery, like Bogdan explained, only focuses on the transmission between C2 and C3. So integration between C2 and C1 or C3 and C4, it's up to the users which choose this solution. Domibus offers, as I mentioned earlier, briefly, 3 standard connectors by default, which are the web service plugin. This provides web service interfaces with SOAP services for C1 to C2 to send the messages, and C3 to C4, C4 to C3 to download the message. There is also a JMS plugin, which provides queue interfaces for interoperability between C1 and C2 or C4 and C3. And finally, the FS plugin of file system plugin, which provides a file system based interface, which basically you drop a file in a folder, and Domibus will pick this message and transmit it to the final recipient. Alternatively, Domibus offers a development API where you can choose to develop your own custom plugin. In this demo, we will be using the web service plugin. And if we have the time, we will go through the FS plugin as well. The steps in the demo, we will be going through the configuration. How do we configure an access point? How do we configure Domibus in this case? There are two main points. The pmode file, which is the pmode stands for a processing mode file. This defines how the access point will behave and what is the set of standards that are going to be used. This can be seen as a way of a contract between two parties. So the access point A or access point B, they need to agree to certain conditions to a contract. So if the message has to abide to this contract, this pmode configuration. We will be seeing a sample pmode from Domibus, where we will highlight specifically the endpoint URL where we configure the party with the access point name and what is the URL where we will submit the message, the party name, party ID, and other attributes, and how to upload the pmode to the access point to have this configuration in place. The second point, which is quite important in the AS4 exchange, is the security. And the security is configured in the case of Domibus via the Domibus properties file. We will show where we do configure the key store and the trust store, which contains the public and private keys for the message exchange. We will go through that in much detail later. Sending and receiving, it's basically backend C1 sends a message to access point C2. Well, it doesn't really send the message, it sends a request as a request to C2. C2, the access point will, let's say, validate this request. And if the request is valid according to the pmode, this contract, let's say, it will produce a valid AS4 message that will be ready to be sent to the recipient access point. Once the message has arrived to the recipient access point, it receives an acknowledgement. This is a non-repudiation receipt. And then the message will be ready in the recipient access point. So the final recipient can download the message anytime. Okay, once the message is downloaded from the corner 3 as well, C4 will get a response. The configuration of the pmode. Pmode, as I explained earlier, is a processing mode. It's a collection of parameters that determine how user messages are exchanged between a pair of access points that take into account the quality of service, transmission mode, and error handling. We can configure a number of parameters which will define how the message transmission will happen. As I said earlier, this can be seen as a way of a contract. Okay, it's a very good analogy, I think, to put in other words. The pmode also allows to identify what are all the access points and addresses of the recipient party IDs, because in this case we are using a static discovery. This is how it looks like, the party configuration. So in this case we have a party name redGW with one endpoint. So the messages that we send to this party will be pushed into this URL. This has to be a public URL, publicly accessible, or at least in the same network of the access point. So there has to be connectivity, network connectivity between them. And the message is pushed via a post HTTP protocol to this URL. And this would be the one for BlueGW. These party names, they also have these different identifiers, which we will use to submit receive the messages. In the case of Domibus, we can upload this configuration directly from the administration console. We will see this later more graphically. We will access the access point. And via this button upload, we will be able to upload the P mode, and immediately it will be taken into account for the message exchange. The security details in the Domibus property file. This is also how it looks like, but we will show a real example. It's basically the same because we are using a sample key store and trust store, which contains sample keys for the demo presentation. And we will go now through a live presentation. I mean, a real showcase of the message exchange. The first step will be C1 will submit a request to C2. In this case, this envelope represents the request. This would be a SOAP request. This request arrives to the web service plugin, the connector in the Domibus, in the corner 2. If the request is correct and it complies with the pmode file configuration, the access point will produce a message ID, will produce an AS4 message, and it will respond the sender with the message ID that has been created. So it will create a SOAP response that will contain the message ID in there. Let's go through an example. I have here one access point called Domibus Blue, and I'm going to use SOAP UI here to submit a message. This will be the SOAP envelope, what it looks like. The main parts that we can identify here is the party information that will contain the sender, which is like in an email from, and the to. So from means who is the sender. The sender will be Domibus Blue, the access point that we saw earlier, and the receiver will be Domibus Red. In this request, as you might have noticed, we do not see the endpoint URL. Domibus will only use the party ID and other identifiers like the party type and other attributes to validate this party. And only in the pmode configuration, we have the endpoint URL. So in here, we are saying we want to send a message from Domibus Blue to Domibus Red. We will use certain services and actions that are also defined in the pmode. And the message itself, it will contain this data. This is just a base64 encoded XML text that will be the payload embedded into the message. So if I click play here, I have gotten a response back here. And this is the response that we have gotten from Domibus. Going back to the slide, this will represent this little envelope here. We have sent this request by clicking play. And after the validation, successful validation, we have received something. This is what we have received that contains the message ID that has been produced by Domibus. So we have some sort of receipt, as if we go to our post office and they give us a tracking number so that we know the status of our message. Next, this is what will happen at C2 while sending the message. The message will be validated. It will be compressed using gzip, the open source gzip. The message will be signed with the private key of the sender that will act as a non-repudiation measure for later. It will also be encrypted with the public key of the receiver so that only the receiver can decrypt this message. Once this has happened, the party will be looked up in the P mode to see what is the access point that has to receive this message. And then the message will be sent with all these, let's say, layers on top. It will be sent encrypted, signed, and zipped to the recipient access point. We can see here graphically how the message has moved. And then what happens at C3? First, please let me show you what we see here in our access point Domibus Blue. This Domibus Blue, as we saw here in the request earlier, this is the sender. So we are sending from Domibus Blue. So what do we see in our Domibus Blue configuration? Let me log in. Here we see a message ID. This is the same message ID that we see here. Okay. If I look for it, this is it. And we see a status and other information, the message ID, from party ID to party ID, the message status, the received date, etc. The status that we see here is acknowledged. It means we have received the acknowledgement from C3 correctly, as we see here. Okay, the acknowledged, it is arrow once the message has been received. Now, what happens at the receiver access point? The receiver access point, it receives a message. First, it will decrypt the message using its own private key. It will verify the signature of the sender using the public key that it has. It will decrypt, it will decompress the message. And it will validate the user. Basically, it will look into its own P mode configuration that this user is a valid user that is expected to send messages. And once all this validation has happened, it will send back the acknowledgement to C2, to the corner 2. As Bogdan explained earlier, this acts as a non-repudiation receipt, meaning that the receiver access point cannot deny that it has received this message. Then the message will stay there in the corner 3, waiting to be picked, as if you send anything to your post office. Well, there are different ways. Maybe the mailman will deliver it to your door, but in some cases, you will just receive a notification. You have a message and or a package, and you go to the post office and take this message. Okay, so this is the representation of the acknowledgement. Once all of these steps have happened, the acknowledgement goes to C2. All this happens really fast. But okay, this is explained very much in detail. Basically, when you send a message, you will see immediately here the acknowledgement. So there is not really a long time that you can see all the steps, but this is what happens internally. And after the message has arrived in C3, C4 will download this message. But first, let's go, as we see here, from C2, this is what we can see. Now we connect to C3. And in C3, we see the exact same message ID, and the status is received. So from the perspective of the receiver, it has a message that has been received. This message can be downloaded. It can also be previewed from the Domibus admin console. But downloading or previewing the message from here does not really mean that the message has been retrieved by the real recipient. So again, using SOAP UI as a client software, we will act now as C4, and we will send the request to C3 to download this message ID. And by doing this, I will also show some of the web services that the web service plugin offers. So as C3, how do we know that, or as C4, how do we know what messages we have received in our access point? So we have a web service called list pending messages. So if I submit a list pending message request to corner 3, I will get a list of messages. I only have one, but later we will show this better with multiple messages. So this is the same message that was sent. So now C4 knows that there is a message waiting to be picked, which is here. So the message is received, nothing else. Now we want to retrieve the message. So we have a web service called retrieve message. So in C3, we define here what is the message ID that we want to retrieve. And this is the response that we get. The response is the message itself. So we see here the complete SOAP envelope with all the messaging headers, the body, the payload, etc. Now, what has happened at C3? That here we saw received earlier. If we refresh the page, now we see deleted. Okay. Deleted means the corner 4 has downloaded the message. And once a message has been picked up by the final recipient, the message disappears from the access point. This is normal. This is as in the post office. Once you take the package from the post office, it is no more in the post office. You cannot take the message twice. Okay, this is slightly different here. You can define what is the retention policy. So, for example, messages can remain for a certain period as a backup measure in the access point, but by default, the messages are deleted once they have been downloaded, as we see in this case. So here graphically we see the request that we have sent. Okay, this will represent the request retrieve message. So C4 sends the request to retrieve the message, and corner 3 will dispatch the message that was received to it, and then delete it. Okay. Just to showcase this in a more real life scenario, let's send a few more messages from corner 2 to corner 3. So I click play again, and I get another message ID here, and another, and another. So we have several message IDs. What happens at C3 if I list the pending messages? This message that was pending earlier has already been downloaded, so it should not be here in this list. And we have 3 new more messages that indeed we can also verify here. We have this first message as deleted because it has been consumed, and we have 3 new more messages received. Again, we can download any of these messages. Let's, for example, pick this one. And I want to retrieve this message. I think I didn't copy it correctly. Sorry. So we have retrieved this message, and immediately we will see here that this message has been deleted. Let's download this one. And again, we shall see the message is deleted. How is this deletion configuration defined? Well, it is defined here in the P mode. We are going to see the P mode exactly as it looks like in this access point in C3. Here we see the party name that is associated to this this access point. We see the parties. the party definition here, as we saw earlier in the slides, very similarly. Let me get back to the slides. Okay, you can see here, and this is the small part where we define the parties, and exactly we have the same here. So this would be the endpoint URL for Red GW or Domibus Red, and this would be for Domibus Blue. They are in the same host, but just in different ports. And we have a section called, let me see. Yes, here, the retention policy. So this is the parameter that defines what happens once the message has been downloaded. So by default, as I was saying, is 0. This means once the message is downloaded, it is automatically deleted. This is defined in minutes. If the message has not been downloaded, it will be available in the access point for 10 days. Let's do a simple test. I will move this to 60 minutes, 1 hour. And all the changes in the pmode configuration, they took effect immediately. So if we go back to the messages, we still have one message that has been received and has not been taken. So now let's see what happens once we consume this message. So sorry. So now if I list the pending messages, there are no more pending messages in the access point. And indeed, we can see that all these messages have been deleted, but this one has only been downloaded. It has not been deleted yet because of this change that we did in the pmode configuration. We have mentioned here, we want to keep the message downloaded for 60 minutes. So after 1 hour, the message will be automatically moved to deleted. Okay. So if we have the time, I'm not sure, Manon, if we still have time, I can showcase a file system plugin.
Yes, sure. Go ahead.
Yes.
Yeah.
All right. Okay. So the file system plugin is quite interesting because it very much simplifies operations. So in certain scenarios, it can be very, very useful. But we have to do a small change in the Domibus that I will explain here. The file system plugin is a connector as the web service plugin, and Domibus needs to know which connector it will use primarily. So here in the message filter, we can see that we have these plugins, backend web service and backend FS plugin. The first one is web service, but now we are going to move FS plugin on the top. So we save this. The FS plugin needs to have a configuration about physical location of physical path in a server. It can be also a network location where we will store the messages that are received in this case. So I have here, I am connected